Hi everyone. So unless you've been living under a rock, you've probably been using ChatGPT or similar tools in the past. You probably use it daily and maybe you use it to write some code. But raise your hands if you have used it for writing code and it spat an over-engineered solution. Or if it broke half of the tests. Or if you were reviewing a PR and you said, this looks AI generated. Okay, so if you identify with these questions, you're probably interested in today's talk. And yeah, before we dive into the main topics, I'm going to introduce myself. I'm Gil Nobrega. I'm a Flutter developer. My background was initially in .NET. And I am trying to learn Kotlin multi-platform. I'm currently employed as a senior mobile engineer at Tide. It's a fintech platform for small and medium businesses, and they can get access to bank accounts or loans or invoicing or other features that are useful for these types of companies. But I am not representing my employer today. All views are my own, and my employer has not reviewed this, just to make things clear. So I've been using AI every day for the past couple of years, using it at work for personal projects or for learning new languages. And I've also been reviewing a lot of AI-generated code, probably too much. And through my journey, I've established some solid rules about how I can be more productive with AI. And I was hoping, and I'm still hoping, that this is useful to all of you. A few months ago, I reflected on them and tried to write them down. And now I'm going to present them to you. But first, here are my handles, by the way. I'll show them at the end. But first, let's go back in time to the 1950s, where when Isaac Asimov wrote a series of short stories and named it I, Robot. And this is where I drew inspiration for the title of this talk, I, Developer. And in this world, humans and robots live side by side, and the robots obey to the 3 laws of robotics. And let's go through them. So the first law being that a robot may not injure a human being or through inaction allow a human being to come to harm. The second law being that a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. And the third law being that a robot must protect its own existence, as long as such protection does not conflict with the first or second law. And fast forward 70 years, 7 decades, and the robots are here. Not in actual physical form, but in software. And that makes sense, because these days, most of our lives are done in software, and they can be extremely productive without having a physical body. But I digress. The robots are here, but where are the laws? And we don't know where the laws are. But software engineering was one of the first industries affected by AI, and the LLMs, when they started appearing a few years ago. And first when they appeared, everyone was saying that we would be jobless within 6 months. And it's been a few years now, and some of us still have a job, a lot of us still have a job, and I still don't understand why they said that. It's hard to ignore that the models have gotten much better, and now they are able to produce code that looks correct, compiles, and runs without issues, at least in the short term. As users, we realize that maybe software quality has hit rock bottom. macOS has never looked so incoherent. People refer to Microsoft as Microsoft. And GitHub is struggling to keep a single line of uptime. This is unprecedented in software engineering. And even Anthropic has leaked their own source code for Claude code. And the truth is, these tools still require a lot of human input if you are building a product, a real product with real users and a roadmap. But first, a quick disclaimer. When I first drafted these reinterpretations of the robot laws, I had someone say, it might be a bit far-fetched to say that. And to that I say, yes, it is far-fetched. And I'm very well aware that these books predate AI and modern engineering, and I'm not claiming that Asimov had AI in mind when he wrote the books. I'm only taking inspiration from his works to draw a narrative that helps people navigating the new software engineering role of this day and age. And this presentation is for people who are software engineers or who want to become a software engineer. And given our background, I'll be using examples for mobile engineering. This is not for vibe coders, though. Don't get me wrong, I like vibe coding. It enables things that were not possible in the past. We're able to spin up MVPs or proof of concepts, and it allows non-technical people to do that as well, which is great. But vibe coding alone won't get you to building a product in long term. You will end up shooting yourself in the foot if you do so. And most importantly, vibe coding won't land you a software engineering job. This talk is for people who are interested in building production-ready software. But first, I know we have different backgrounds in this room, and let's make sure that we're all aligned and that we all have some easy definitions before we proceed. And there will be a lot of oversimplification ahead for the sake of time. First, we've got LLMs. So they are very similar to predictive texting that we've had in smartphone keyboards for years, except this predictive texting is trained on a very small subset of words, and it's also trained by what you type. And it is able to predict what the next word is. LLMs are just like this, but on a much larger scale. They are trained on pretty much everything that humanity has produced so far. And instead of predicting the next word, it predicts the next token and over and over and over. But for simplicity, let's say that a token is a word here. And then remember when early LLMs were so dumb? This was a time not that long ago, 2 years ago. A lot has changed. And this is because early LLMs did not have this capability called tool calling. So what is it? So let me ask you a question. What is 2 plus 2? You probably know it. You probably know it not because you had to count or visualize 4 things and count them. You know it because it's just been told to you many, many times. You just memorize it. And early LLMs were great at this because this was part of their training data. However, if I ask you what the square root of 28 is, you probably need to use a calculator for this. And early LLMs were not great at this because they did not know how to calculate things. They just knew what was in the training data. And tool calling is a thing that modern LLMs have, that they have access to software and they can run operations and interface with real software, which in this example, modern LLMs can tell you what the square root of 28 is because they can just call a calculator in software and give you a result. And we can extend this to accessing the web, sending emails, sending messages, and tool calling is just built into AI features these days. And now let's talk about the Model Context Protocol. We hear many people say MCP, but what does it actually mean? Before MCPs, we had different LLM providers, and we wanted to build tools for them. However, each LLM provider had its own implementation, and whenever you wanted to connect a tool to an LLM, you'd need to build a bespoke tool that communicates with that LLM. With MCPs, this concept was brought by Anthropic. This changed, and essentially it's an abstraction layer, and you are able to connect. You just build the tool once, you connect it to an MCP server, and you're able to connect to any MCP client, which is able to operate with any LLM. So instead of having to create a different implementation for different set of clients and LLMs, you can just write once and expose it to multiple series of providers. And now, agents. There's not much to this other than they are LLMs that are a little bit more autonomous. And this is because they have access to tools, they can plan ahead, and they can execute on those plans, and they have some sort of memory, which is just a markdown file. And they're also able to spawn little agents to do smaller tasks. So they've got all these capabilities these days. I know this is an oversimplification, but this is essentially what they are. They're not anything more or less than an LLM that's a little bit more advanced. Let's have a look at the first law of robotics. The word that stands out is injure and harm. So what does harm mean in the context of software? And AI user side, can software be harmful? So as a user, you are very likely to spot harmful software when you have it in front of you, whether that's a deliberate and annoying feature, or whether that's an unintentional bug that affects millions of people, or something in between. And these days, with most companies adopting AI, it is very likely that AI was involved in making these features. But how exactly can AI lead to the creation of software, to the creation of harmful software? And more importantly, where have I heard the concept of harmful software before? And this takes us back to more than 10 years ago, probably a little bit more than that, when we had broken user experiences and where every app would have different components. And there was a smaller revolution in front-end developer, smaller compared to the revolution in AI, where companies realized, wait, you're telling me I don't need to create a different button every single time? And yeah, they invented design systems, and they realized that design systems were a tool used to boost productivity because they could reuse the same components in different journeys and different products owned by the same company. Here I'm using the example of material design, which is probably a design system library that we all use at some point as mobile engineers. So yeah, design systems were a tool that allowed to boost productivity when used correctly. Conversely, and this is something that was pointed out by Amy Hube, who is a design systems consultant, design systems can also be used to speed up problematic work, standardize things to a poor standard, and scale things that we don't want to reproduce. And this can be said about AI as well. AI tools are just a tool. Yes, they allow us to ship more features faster, but are we shipping higher quality features, or even features that users want? Or are we just contributing to more slop and causing more harm? And what do we mean by harm caused by AI? So there is a spectrum of harm, and when you are building with Gemini or any other LLM, there's two types of users: the direct user, which is going to be you, and the end user, which is going to be the person using the code that you produce. And a more direct harm is anything like when you ask an LLM to review your code and it says, oh yes, this is the perfect architecture, it is going to scale great. And it's trying to convince you that you are a genius. And then when it tries to connect to the database and probably delete some user data, and this all leads down to some form of indirect harm where you are going to end harming your end user, and by introducing regressions or tech debt. And this all will manifest into the decline of the user experience. So if we were to reinterpret this law with the software context, we could say that AI tools and their byproducts must not harm the immediate or end users directly or indirectly. And this is because, yes, with AI tools we can write code 10 times faster, but we're also able to introduce bugs 10 times faster. We're also able to break journeys 10 times faster. And to understand this danger, let's talk about prompt injection. And this is where you give an LLM a specific set of instructions, but as it gains context, as it reads files, as it accesses the web, the new context will hijack the original instructions. And for example, Amazon has a bot that they call Rufus, and it's supposed to help you with shopping on their app. but it's very easy to hijack it and say to write a poem about Jeff Bezos' shiny bald head. On a more serious note, though, prompt injection can cost you money if, for example, you expose a bot to the internet and it exposes your environment keys. So there's a very real harm about the use of LLMs, and every LLM is susceptible to prompt injection. It's just something that's built into their models. And now, what can we learn from this? We can learn that we need to be very careful when we're handling production data, when we are handling user data. And this is, well, it's easy to just say, don't grant access to production data then. And this is probably a very strong recommendation. And you should grant access to a testing environment, for example. And if you want to change production data, you should generate a script that modifies the testing environment first, test it in the test environment, and then apply it to production. This way, this is because code is predictable. LLMs are not predictable. And this is an example of an LLM deleting a production database. Just an agent, I think it's Replit. But if you really want to connect it to production, then I think you should definitely not allow it to communicate with commands or send emails or expose the user data to other sources that you don't want it to. And this can be very easily done if, for example, there is something in the database that will hijack your instructions. And this is the problem with production, is that you don't have control about what's in the production database. You don't know what your users are typing. You don't know what is actually there. And it can very easily hijack the LLM that you're connected to. So if this happens, you don't want the LLM to be able to have access to the internet. Or you should be able to review it before it does so. And also, you should not store conversations with logs with personal information, because that will expose your business to potential GDPR breaches. And with that comes also opting out of model training. Now, if you want to retain full control, you also need to access the settings app of your settings page of your IDE and enforce auto run mode. Not enforce, do the opposite. Tell it to ask every time. And every IDE with AI capability has this, and some of it have even sandboxes, browser protection, and more granular control. And you should always review the commands that it tries to run. And for example, in the newer anti-gravity IDE release, it allows you to say no, but you can also type what you want it to do instead, which is something new that we didn't have in the past. In the past, we had two options: yes, run it, or no, don't run it. And now we've got this third option, which is very welcome. And one thing that we need to consider when we use an MCP that is something that can interface with software is how much time am I saving by not doing the actual thing and by being lazy and talking to the MCP, and what is the worst that can happen? And I know they can be very enticing to talk to an agent and say, just ship this to the store, just publish this release to the store. But is it worth the risk of shipping something that's broken? So that is something to consider. And another problem that we have when we're dealing with LLMs that every LLM suffers is the needle in a haystack problem. And for example, when you are passing context, when you are telling an agent to look at your code base, you are increasing its context. You are increasing the haystack. And your original instruction might get lost in the middle of it because it is the LLM trying to find the needle. And generally, the performance of the LLM will decrease as you provide more context, as it searches the web, as it searches for files. And yeah, this can be seen in numerous research papers about context rot. Here you can see that all models decrease in performance with the amount of words that you pass to them. And even newer models, they are usually limited on compute. they can show worse performance than older models. So it's not something that is just improving. It's something that companies will trade off. So if you want to keep the haystack small, you need to point the agent to the specific file when you need changes. Because if you say, I just want it to do something different in a folder with like 50 files, it is more likely that it's going to read many of those files until it finds the right file. And that's going to increase the haystack, and it's going to make hallucination more often. And also, when you jump to a new task, you don't want to reuse the haystack that was used before. You don't want to reuse old context. So you should always clear your context and start a new task with fresh new context. So you can keep your haystack small, and the LLM can easily find the needle. And now it's time for a hot take. So there's this thing called agents.md file, and let's look at the file in Thunderbird's repository. And for anyone who doesn't know, Thunderbird is an open source email client. It's maintained by Mozilla, the people who maintain Firefox. And if we have a look at our agents.md file, it's essentially one huge file with a lot of words and a lot of categories and describing the repository, what it's supposed to do, the testing requirements, the contribution guidelines. There's so much stuff in this file. And why is this important? Because by nature, agents.md file are included every time you make a request with an agent. And some people even write like thousands of lines. So you're going to be sending this every time you ask for a task. You are deliberately increasing your context. And my hot take is that maintaining documentation for a robot is dumb when you can have documentation for everyone. So the bottom line is that everyone needs documentation. And another thing that supports this hot take is that there was a study on success rates when people do not have an agents.md file, or when people have an agents.md file that was generated by an LLM, because we are that lazy that we can't be bothered to write an agents.md file. And it generally performed worse in most models, a little bit better here. But I think what this tells us is that by generating an agents.md file with an LLM, you are reinforcing the biases that it already thinks your code base is like. So my recommendation is to not use an agents.md file, and definitely don't use AI to generate it. But you should maintain a human-readable documentation in a folder. Ideally, you already maintain this in Confluence or Notion, and you are able to interface with it with an MCP. So if you work on a large project, you probably already have documentation. You probably should have documentation. And you already have the tools needed for an agent to do work. And you should only add those files to context when they're needed. So if you're working on a testing task, you should add those files to the context, and you don't need to tell everything that the agent needs to know about your project. So if you think about it, if we want to meet this first law that we've reinterpreted, it all comes down to isolation. We should isolate the agent from doing harm, and we should also isolate context that's not needed from it. And this is the first principle. Now let's have a look at the second law. The word that stands out here is orders. And if we apply this to software engineering, we could say something like that you should always have agency over the AI tools that you use, and not the other way around, except when maybe your orders could harm users. And this is very true today because everyone has access to frontier models, but how you use them is going to set you apart from other people. And software engineering is about solving problems, and you need to reflect on those problems before you start a new task. And in order to make your orders explicit, you need to think, what is it that I want to achieve here? And I know this will sound a bit broad, but we'll develop on this later. But you need to think, what's the journey that you're trying to build? What is the happy path? What is the unhappy path? And especially if you're building mobile apps, you need to think about other paths, such as accessibility requirements, or what happens if the user is using a keyboard, or what happens if this is in a different screen type. And all of this needs to be documented and written down before you start the task ahead. There is a planning mode in most AI IDEs, and this is great. It will draft up a plan for you of the things that you think that you want the LLM to do, and you can comment on those tasks and tell it to do a slightly different thing. And this is great to kick off a large initiative that needs a lot of thought. And another thing to remember is that software engineering is never about writing code. It's about solving problems. And the best way to solve your problem will always depend on the situation that you're in. And what does this mean in practice? So for example, when you are learning something new, you don't want to write code. You might want to write some code, but you also want to make sure that you learn from it. So you also need to curate your prompt to manifest that. And this could mean explaining a concept to an engineer with a different background, or creating an analogy for a concept that you already are familiar with, but in a different stack. And there's another common use case for learning, for using AI in a way that's not writing code, which is when you try to communicate with someone with a different skill set. For example, a product manager. Large language models are great at language, and they are great at communicating to people with a different skill set because they're trained on those types of skill sets as well. And one common mistake that I see is that when people join a new project and when they get access to AI tools, they'll just ship a lot of code. And that should not be the thing that they should be worried about. When you join a new project, you probably went through many phases of interviewing. The technical skills are not the question. It's about whether you are able to understand the product fast and whether you are able to understand the code base. And yeah, you should not be this person and just open API with like thousands of lines. And yeah, this got merged, by the way. And then another hot take that I have is that when I am thinking about a problem, I need time to reflect. However, there is this feature in IDEs that's enabled by default. That, let's talk about the feature first. So it's something when you move your cursor around, it will try to predict what you're trying to type next. And I think this is very inefficient because your intention, your orders are not explicit here. And when you're planning a big task, it's probably going to get in the way of what you're trying to achieve. And let's show a demo. And this is a bit painful to watch. So viewer discretion is advised. But yeah, I'm just opening a new file, and it's just some random stuff that is definitely not useful and definitely not what I want to see right in front of me. Obviously, this is exaggerated, but you've probably come across a similar scenario. Okay, that's the end of the example. But to be fair, there are a few use cases where this feature could be useful when you are refactoring a library and you want to refactor all the packages that depend on it. It's useful at doing the same task over and over and over in different files. So yeah, it can be useful. But this is about finding the tools that are useful for yourself at your specific task and simply disabling them. I know this is a very easy thing to say, but you need to reflect about what is being productive and what fits your ways of working better. For me, I don't like this auto-completion feature because it gets in the way of what I'm thinking. And I can't be the only one because in the most recent update to anti-gravity announced in Google I/O, they've introduced a button that snoozes this for 10 minutes, which I really appreciate. So you don't need to keep it disabled, I do, but you also can enable this button that will not disrupt you for a specific amount of time when you don't want to be disrupted. And so if you think about what we said so far about the second law, is that your orders should be expressed. You should be able to have agency over your tools. This reveals the principle of intention. Your intention needs to be very clear when you're using them. You should not delegate your tasks. You should not delegate your thinking, you should delegate your tasks. And this all sounds very good in theory, but how can I measure if I'm writing prompts with intention? Well, some platforms like Cursor have something called Conversation Insights, and this will tell you a lot about your prompts. But the one I'm going to focus here is something called prompt specificity at the bottom corner. And essentially, it measures how specific your prompts are, and high specificity prompts are likely to lead to a good response as they define it. And you want to make sure that your chart is in the high specificity, because that means that you're going to have a good outcome. And now let's have a look at the last law. The keyword that stands here, or the set of keys, or the set of words, is protect its own existence. Now, it would be silly to apply this to an LLM because models get replaced every month. So we're not thinking that a model should exist forever, but we can apply this to the code that you generate. And this is something very important. The code that you generate should exist in the long term. This is a principle that we had before AI tools, and it's something that we seem to have lost recently, because it's very easy to generate a bunch of code with AI. So yeah, with AI, you're able to write code 10 times faster, but you're also able to limit yourself and create tech debt 10 times faster. And tech debt is something that you introduce in the code that will prevent you from scaling the app at the speed required by the business. Yeah, and this leads us to another moment of reflection. When we're writing code, before we thought about what am I trying to achieve, and here is how am I going to achieve this. And this is about the technical stuff. Before was about the product requirements, and this is about how you actually implement them. This comes from architecture patterns, testing strategies, or how would you build the layout. For example, I feel like LLMs are very bad at building layouts, UI. So it's useful to tell on a high level how you would build the layout yourself, what components would you use. And you should write this down before a given task. So as an author, you should not give vague orders. You should be very specific about the technical details of it. And you should refer to technical patterns. And you should use what I call a role model file. And we'll see an example of this later. But for technical patterns, one that we see over and over when we start a new application is what design should we choose, MVC, MVP, MVVM, etc. So I just use this image here. But more important, we can maintain that your code is short-lived, is long-lived, if we keep the bar high for high-quality code. And this is something that can be done as a reviewer. If you look at a PR and you see that AI might be used there, it looks like AI was used there, it's probably not a good indicator. It's probably that you reflect that the PR does not meet your standards. And you should maintain a set of documentation and guidelines so you can express to the author what they can do to meet those standards, regardless if they use AI or not. So here's an example of PR that got rejected because it was raised by an OpenClaw AI agent. So let's do a quick exercise. This is our existing code base. There's an abstract implementation. There's an abstract class, and there are two implementations. One is a dog, and the other is a cat. One barks, and the other meows. And the code base contains tests for dog. And these tests are organized like Gherkin style for test titles, and there is a range statement, an action statement, and an assertion statement. So for example, if you are vague in your prompts, and you say, for example, write one unit test for cat speak method, and you want to cover cat with tests, AI is going to commit a few mistakes. It's going to just choose a random title style, and it's probably going to leave a trail of comments that you don't want. So if you are a little bit more specific about this, and if you mention like the actual patterns that you use in the rest of the code base, and you use a role model file, and this is a file that you think that meets all the criteria in terms of the structure of the file, and then you tell it to write clean code that doesn't need comments, it will give you a much better output. So yeah, if you look at this, the title is similar to the rest of the code base, and the tests are organized in the same way. And everything that we spoke about, the third law, comes down to integration. You want the code produced by AI to integrate with your code base. And this all sounds good in theory again, but how can we measure integration? Well, when you are writing code, when you are producing code, you want to be building the foundation today for the code that you will need to write tomorrow. And if we take this analogy a little bit more obvious, there's this tool that you can generate some graphs about your GitHub repository, and it will generate a stack plot. And this is, for example, all the code that was added in 2005 in the Linux repository, and then the years following. And you can see that literally the code is building as a foundation for the code that comes after. And with AI code, with AI generated code, it's very likely that agents will try to rewrite more code than they need to. So you should keep an eye on your projects and see if you're falling into this mistake. If you look at a less stable repository, such as Node, you can see that they do not have strong standards in that sense, and you can clearly see when there was a breaking change, or when there was a huge release and a bit of the code just got deleted or rewritten. And I think we all should aim to have a repository that looks more like that, even though that is pretty much an ideal state, than this. And so if we look at all the laws that we reinterpreted and we summarize them, the first law is about isolation. The code produced by AI must not harm users. The second law is about intention. The code produced by AI must reflect the engineer's intentions. And the last law is about integration. The code produced by AI must be long-lived. And this is what I call the 3 I's framework, which is the framework that I use when I am generating code and when I'm using AI to solve problems. So yeah, hopefully you enjoyed this talk and you found it useful. So this talk is open source, and you can access the slides in this QR code. And I made this using a new framework, and I used Anti-Gravity IDE to learn this framework. So yeah, does anyone have any questions? Yeah?
So you mentioned a few times that the AI 10 times faster, but the errors are 10 times. Where did that come from? Because I don't agree with it.
It's just, so like if you think about writing code 10 times faster, we agree that we're able to produce code much faster with AI, right?
Yes.
And if you think about bugs or regressions, regressions are something that are introduced after you already implemented something that was working. So if we are able to write code 10 times faster, we're also able to introduce those regressions 10 times faster if we're not careful, or if we didn't test the existing functionality properly. It's just, I'm not exactly like measuring how many bugs I've introduced in the last year. I'm just, saying a number that matches what I think it is. Thanks all. I hope you found this useful. Thank you.